Hello, pre-calculus students. Today we're going to start on quadratic functions, which when we graph them are parabolas. So let's take a look at this first slide. We need to define what a polynomial is. So n is a whole number, and if you recall, the set of whole numbers start with 0, 0, 1, 2, 3, etc. A polynomial in the variable x is of this form. Now, a sub n just means a constant, a number, times x to the nth power. Then a sub n minus 1 just means a different a value, x to the n minus 1. And we start at a to the n, x to the n, and we just keep decrementing it 1 unit until we finally get down to a sub 0, x to the 0. And we know that if x isn't 0, x to the 0 is 1. So this is a constant. So you have a constant plus something times x plus something times x squared plus something times x cubed, all the way up to your highest power of x. These a values can be complex numbers, but we're really only going to focus on the real values. So this is the definition of a polynomial. Now, from the test that you took, we should recognize this as a circle centered at point HK with a radius of 10. If you solve this for y, you see it's y equals k plus some number and y equals k minus some number. Bottom line is this is not a function, as it's a circle and it fails the vertical line test, because you can see for each x, there could be two y values, k plus something and then k minus. So that's not a function, and nor is it a polynomial, because we have this square root here. In our definition of polynomials, all of our exponents of our quantities were whole numbers, and a square root is an exponent of 1/2. So can't have a 1/2 in there and have a polynomial. Neither can you have a 1 over x, because that's the same as x to the negative 1, and negative 1 is not a whole number. So, graphing parabolas. Parabolas are of the form ax squared plus bx plus c, where a is not equal to 0. If a is 0, then you just have a line. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward. The vertex of the parabola, to find the x coordinate of the vertex, that turning point, it's negative b over 2a. Then you substitute that negative b over 2a, that x value, into here, and you get the y value. Where does that negative b over 2a come from? It comes from the quadratic formula, where you have negative b plus some quantity and negative b minus some quantity. At the vertex, let's see, you're not going to have 2 points crossing the x-axis. You're only going to have 1 point crossing the x-axis, or touching the x-axis. So this is going to be your 0 value. And you say, what if it's not on the x-axis? Well, we can translate axes. Not important for us to get into that here. Just understand that the negative b over 2a comes from the quadratic formula. Now, different books have different titles. I always learned standard form as ax squared plus bx plus c. Your book uses, our current book that we're using, uses this as standard form. Some books will call this factored form. Some books will call it vertex form. But if your vertex is a coordinate hk, then you can bring this y minus k, you can bring it over to the other side. So hk is the vertex. So as I said, some books will call this factored form. But both of these forms give us different information about the parabola. But this a and this a are the same a. So let's work through an example. So here we are in ax squared plus bx plus c format. To find the vertex, we go negative b over 2a. That's negative 8 over 4, which is negative 2. Substitute negative 2 in for x, and we get negative 14. So the vertex is at coordinates negative 2, negative 14, and because a is positive, the graph opens upward. Let's write it, let's complete the square, and we should get the same hk values. So we want to write it in this format. So what we'll do is we'll bring this 6 to the other side of the equation, and we'll factor a 2 out of what's left. Now, to complete the square, you need a 1x squared here, which we have inside the parentheses. You take half of this term and square it. So I added 4 in here, but on this side of the equal sign, I added 2 times 4, which is 8. So I have to add 8 to this side of the equal sign to keep it balanced. Subtract the 14 from both sides, and you can see that we do in fact get the same vertex, negative 2, negative 14. I expect that by this time in your math education, you should be able to follow this, and in fact should be able to do this. To find the x-intercepts, if any, in a parabola, you set y equal to 0 and solve. So here, in this parabola, y equals x squared minus 6x. You factor it. Now you have what we'll use what's called the zero product property. If you're multiplying two numbers and the product is 0, then one or both of the numbers is 0. Now what some of you will want to do, and I wrote it over here in red, the color of blood, because it's bad, bad, very bad, is you'll want to bring this negative 6x to the other side, divide both sides by x, and you get 6. Well, by dividing by x, you may not notice this, but you actually made the assumption that x isn't equal to 0 because you can't divide by 0. But in this problem, x can certainly equal 0. That's why you need to factor, not cancel and divide an x out of both sides. On a parabola that opens either up or down, the vertex will be either the maximum or the minimum y value on the parabola. If it opens upward, then the vertex is the minimum value of the function, which is the minimum y value. If the I'll skip that. So 2, 1 are the coordinates of the vertex. The minimum value of the function is 1 because the function is the y values. So if I ask for what is the minimum value of this function, you do not tell me 2, 1. The minimum value of the function is 1. Since this is a polynomial, the domain is the set of all real numbers. We've already learned that. And on this graph, the range is y is greater than or equal to 1. If 1 is the minimum value and it increases forever, then y must be greater than or equal to 1 at all times. Alrighty, so how do we factor polynomials? Because it helps to do that if we're finding the x-intercepts or the zeros of a function. I use this little x method. I put, so there's A, B, and C. And the A, let's see. Oh, yes. The B is -3, and I take A times C, so 2 times -35 is -70. So the -3 comes here, the negative 70 goes here. If there are two whole numbers that multiply to give this and add to give this, then the polynomial is factorable. If those two numbers do not exist, then it is not factorable. So I need two multiples of negative 70 that add to negative 3. Well, those are negative 10 and 7. And you'll notice I've circled all three of those. And the reason I've circled those is because I'm going to rewrite negative 3x as negative 10x plus 7x. Now I can factor the greatest common factor out of these two terms, and that's 2x, and I'm left with x minus 5. I've done this correctly. There should be parentheses over here with x minus 5 in them as well. And sure enough, if I take a 7 out of these two, get x minus 5. So now I can factor an x minus 5 out of both, and I'm left with 2x plus 7. And if I FOIL this, it's 2x squared plus 7x minus 10x is minus 3x minus 35. I factored it correctly. What if I do it in a different order? I put the 7x here and the negative 10x here. And you can see that it still factors to the same two factors. If I want to factor the polynomial 4x squared plus 3x minus 1, again, I bring the 3 down, and then 4 times negative 1 is negative 4. So there's my 3, there's my negative 4. I need two numbers that multiply to give negative 4 and add to give 3. How do you remember that it's multiply to give this? Well, you got this number by multiplying the 4 and the negative 1. And then actually, 4 and negative 1 multiply to give this, add to give this. So I rewrite the 3x as 4x minus 1x. Now, many of you might not think to put this 1 in here, but when you factor the x plus 1 out, it's not just a 4x left, it's 4x minus 1. And you had to factor out a negative 1 here in order to get another x plus 1 in the parentheses. If you went negative x plus 4x to rewrite the 3x, you see it still works. And if we graph that same, or we graph that parabola, the same polynomial there, we know that the x-intercepts are going to be where y equals 0. So I've factored this already. Now I know that either 4x minus 1 equals 0 or x plus 1 equals 0. That means x is equal to either 1/4 or negative 1. At either of those x values, y will equal 0. So those are going to be my x-intercepts. Where will the vertex be? Well, because of polynomial, or because a parabola is symmetric about its axis, the vertex will be halfway between these two numbers, or at least the x-coordinate of the vertex will be halfway between those two numbers. Or I can look up here and go negative b over 2a. And again, as I said, it's either negative 3/8, or you average these two numbers and you get, let's see, add them, you get negative 3/4, divide by 2, negative 3/8. So either way, the x-coordinate of the vertex is at x equals negative 3/8. And the axis of symmetry, the line that would run through the middle of the parabola, is x equals negative 3/8. I know that was kind of rushing through that material, but in theory, you could always stop the video and write down what you need. So I hope you got some good instruction out of that. Have a great day.